Welcome to Chapter 7 Ionic Equilibria Titration. Let's learn how to identify suitable indicators for acid-base titrations. Indicator is a substance, where it can be weak organic acid or base that change colors or near at the equivalence point. An acid-base indicator is a substance of which an acid component has one color, whereas the base component has a different color. Okay, now let's look at one example. Indicator for weak acid and strong base. Okay, so first of all, we need to choose an indicator which the endpoint of the pH range lies on the steep part of the titration curve. This ensures that the pH at the equivalence point fall within the range, which the indicator changes color. Okay, now let's recall the experiment that we have done before. Okay, so for example, you are using phenolphthalein. When you titrate weak acid with strong base, when you have weak acid and strong base, you have basic salt. Means that you need to choose an indicator which will change color when the range is at this part, okay, at the steep part here. Okay, so our pH calculated at equivalence is 9. So means that at 9, pH 9, it will change color. Now let's look at the chart. Okay, this is some common acid-base indicators. Okay, so let's learn how to identify indicators, suitable indicators. Okay, so first, suggest indicator for a titration of nitric acid with potassium hydroxide. Okay, so identify first. HNO2 is a weak acid. KOH is a strong base. So if we have weak and strong, we follow the strong one. So we have basic salt. So if basic salt pH is larger than 7. Okay, so at equivalence point, we will have conjugate base of weak acid. At equivalence point, pH is greater than 7. Okay, so let's look at the chart here. 2.8 is until 2.8 only. Then after 2.8, okay, after 2.8, it will be yellow color. Okay, for bromophenol blue, same thing. 4.6, 4.4, 6.3, 6.4. Okay, now we look at this. Okay, it's 7.64 bromo thermal blue. Okay, but however, our pH at equivalence point is more than 7. So it can be 7.9, 7.8. So means that it will change to blue color and we don't know whether it has reached its equivalent or not because it will no longer change color after 7.6. Okay, then we look at cresol rate and phenolphthalein. Okay, if cresol rate, it is 7.2 until 8.8. Okay, so means that the pH at equivalence, if it's more than 7, it can detect. Another one, we can use phenolphthalein because phenolphthalein is between 8.3 and 10.0. So you can calculate the pH at equivalence point first, and then you can choose which one to use. Is it cresol rate or phenolphthalein? Now let's look at this. Okay, let's say now we have phenolphthalein and methyl orange. Okay, so which one shall we use? Okay, if we have strong acid and strong base, we will have neutral salt. If it's neutral salt, the pH will be equals to 7. So the equivalence point is at 7. But however, let's look at the phenolphthalein range where it changes color. It is from, okay, just now we have looked at it, it is from 8.3 to 10. Okay, how about methyl orange? Methyl orange is from 3.1 to 4.4. Okay, so maybe I write it here, 3.1 to 4.4, 3.1 to 4.4, and then phenolphthalein is 8.3 to 10. If you use methyl orange, after 4.4, pH 4.4, it will remain yellow, no more changes of color. If it's phenolphthalein, it will be colorless before it, even after it reaches 7, it is still colorless. So phenolphthalein and methyl orange is not a suitable indicator when strong acid and strong base reacts to detect the endpoint. Okay, how about strong acid and weak base? If strong acid and weak base, we have acidic salt, which is less than 7. Okay, if it's less than 7, okay, so between phenolphthalein and methyl orange, we will choose methyl orange because the range lies between 3.1 to 4.4. So possible that methyl orange will be a suitable indicator. Okay, now next one is weak acid and strong base. Okay, so we will get basic salts where the pH is larger than 7. Okay, so let's look at this now. Okay, just now we said that phenolphthalein is 8.3 until 10. So it's more than 7. So between methyl orange and phenolphthalein, we will choose phenolphthalein as the suitable indicator. So remember, calculate the pH at the equivalence point first, and then look at the pH range for all the indicator. Then only you will determine which is the most suitable indicator. Okay, so that's all for indicator for titration.